This is Mr. Martin. These are the video notes for Geometry Honors Section 5.5. In Section 5.4 we took a look at the basic definitions of our special quadrilaterals. And really the definition is the bare minimum that we would need to define these figures. So, keep in mind that even though the definitions are the bare minimum, each of those special quadrilaterals has many properties that you're going to have to know. So, as you go through this, we'll do it for parallelogram, but what I want you to do is I want you to draw yourself the special quadrilateral and then list off, based on an example that you draw, all the different properties. You have to go through the properties to make sure that you are familiar with them, and really most of them are pretty self-explanatory and pretty common sense, but you want to make sure that you go through these. So properties of a parallelogram: if a quadrilateral is a parallelogram, then we have these 5 properties, and the properties build from one another. So if we were going to prove these, first we would prove number 1, then we would prove number 2, and so on until we got to number 5. So the order that these are in is really important. So I'm going to go through the first one here with you, and then I want you to do the rest on your own. And if you have questions about what you've done, make sure you ask me in class. So we've got A, B, C, D. And we would be given that we've got parallelogram. And incidentally, the only one that we have a symbol for is parallelogram. Given parallelogram A, B, C, D. Okay, so I'm just going to list off what we would know based on this being a parallelogram using the numbers. So number 1, we would know that segment AB is parallel to segment DC. And then based on number 2, also we would know that AD is parallel to BC. And then we would also know that these are congruent. AB is congruent to DC, and AD is congruent to BC. So that's number 2. Opposite angles are congruent. So number 3, I would have angle A congruent to angle C, and angle B congruent to angle D. And then number 4, any pair of adjacent angles are supplementary. So this is going to be 4 separate things. So I would know that angle A is supplementary to angle B, or angle B is supplementary to angle C, or angle C is supplementary to angle D, and then lastly angle D is supplementary to angle A. Okay, so we know all of these things are true. When you're using, so if you're given a parallelogram, if you're using these in a proof, you could just simply say opposite sides. If we're using number 2, for example, we would say as our reason, opposite sides of a parallelogram are congruent. Okay, we don't need to state these in if-then form. So what I want you to do for the rest of these properties of rectangles, we've got all the properties of a parallelogram. So you don't have to go ahead and do all of those because it's going to get kind of lengthy, but do the ones for number 2 and number 3. So draw yourself a picture, write that you're given that ABCD is a rectangle, and then write the properties based on what you know there. So we've got rectangle, we've got a kite, we've got 5 properties of a kite, and then again we could do a proof, and we would prove these one right after the other. And then 3 through 5 for the kite are sometimes called half properties, because when we get to rhombus, these properties, which are only true for half of the figure for a kite, they're true for the whole figure. So one diagonal is a perpendicular bisector of the other. Only one diagonal is the perpendicular bisector of the other. With a rhombus, both diagonals are perpendicular bisectors of each other. And then one diagonal bisects a pair of opposite angles. You have to be really careful with these 3 because it's only true for half the figure. You've got to know which pair of angles is being bisected. And number 5, one pair of opposite angles are congruent. Not both pairs, so you need to know which pair of opposite angles are congruent. So go ahead and draw your figure, write that you're given a kite, write your conclusions based on these 5 properties, and then ask me questions if you have it in class, or if you want me to take a quick look. Alright, so that's a kite. Then we've got a rhombus. We've got 6 properties here. Again, all the properties of a parallelogram apply, so you don't need to do those again. All the properties of a kite apply. And then we've got 3 through 6 here, so make sure you read through those and you understand those. We've got our square, and then isosceles trapezoid. So again, if you are asked to prove any property of one of these properties, you may use the properties above the one you are proving, but not the properties below, because they are in order. Alright, so for example, if you needed to prove property 4 of a kite, you could use properties 1, 2, and 3 to help you prove it, but not property 5. Okay, so we've got a proof here. If you want to pause the video and see what you can do on your own, feel free. Otherwise, you can work through it with me. We've got that A, B, D, C is a parallelogram. Okay, so knowing that it's a parallelogram, we have a ton of information. We've got all those properties of parallelograms that we can use to help us. We've got opposite sides parallel, we've got opposite sides congruent. So we've got CF congruent to BE, that's also given. We've got opposite angles congruent, we've got adjacent angles, any pair of adjacent angles supplementary. So what we want to do is we want to prove that these little segments here, AE and DF, are congruent. Let's see, I've got CF is congruent to BE, so those are the overlapping. So what I'm going to try and do is I'm going to try and prove that these 2 little triangles on the outsides are congruent, and then AE and DF are just going to be corresponding parts. So since I've got CF and BE congruent, I know that CE is congruent to BF, and we're simply subtracting out this middle segment here. So if a segment is subtracted from congruent segments, then the differences are congruent. So now I've got this segment congruent to this segment. Since it's a parallelogram, I know that these sides are going to be congruent, and I also know that they're going to be parallel, and I'll show you how I'm going to use those in a minute. So I've got AC congruent to DB. Make sure you name it in the corresponding order since we're using these to prove triangles congruent. And then you would just simply say opposite sides of a parallelogram are congruent. And I've also got that AC is parallel to DB because opposite sides of a parallelogram are parallel. So now that I've got these opposite sides parallel, if I take a look here at angle 1 and angle 2, hopefully you can see what kind of angles these are. These are alternate interior angles, and since the lines are parallel, we know that those angles are congruent. So I've got angle 1 congruent to angle 2 because parallel lines implies alternate interior angles congruent. And now I've got enough to prove that these triangles are congruent. So I've got AEC, triangle AEC is congruent to triangle, let's see what I got here, DFB, and this is by side angle side from steps 3, 4, and 6. And then once I have the triangles congruent, I know that AE, segment AE is congruent to segment DF by CPCTC. Alright, so if you have any questions, again, make sure you write those down and ask me the next time you see me in class. Otherwise, we'll see you next time.